your applications of derivative quiz, what is the slope of the line tangent to the graph of y equals natural log 2x at the point where x is 4? So first thing we'll need to do is slope, that means derivative. So I'll find the derivative of this function, y prime, and the derivative of natural log is the reciprocal function, and this is also the chain because we have an inside function, so 1 over 2x times 2, and that's just 2 over 2x, which is just 1 over x. Y prime at 4 is just 1 over 4. Number 2, the function has a first derivative. At what value does it have a relative maximum? So the maximums and minimums occur where the derivative changes from positive to negative, negative to positive. For a maximum, it's going to change from positive to negative. So we need to find the zeros of the function. And so the first factor will just give us x is 0. The second factor will give us x is 3. And the third factor is negative 1. Put these on our number line and we'll test the intervals. If you take a value less than negative 1 and plug it into each of the factors, we're going to have negative, positive, negative. So this interval is positive. I'm going to take negative half and plug it in, and that's going to give me a negative overall. If I take 1 and plug it in, that gives me a positive interval, and then something larger than 3, and that gives me a positive. And so to find a relative max, that's where the derivative changes from positive to negative, and so that's at just negative 1. Number 3, for the interval 0 to 6, the graph of the derivative is the piecewise linear function. F of 0 is 1. What is the maximum value of the function? So when you're looking for a maximum, again, that's where your derivative changes from positive to negative. And so we've got this guy right here. And so I'm looking at what this maximum value is. Well, that's at an x value of 3. So I'm looking at the interval from 0 to 3. And this is of f prime of x. And so dx, I guess. And so this is equal to f of 3 minus f of 1 using your fundamental theorem. And so if I were to calculate the area under this curve of a base of 3, a height of 2, divided by 2, this area right here is 3. And then f of 3 is what I'm looking for. F of, this should be a 0, is equal to 1. And so if I add the 1, I'm going to get f of 3 is equal to 4. And that's the maximum value. Number 4, the function is differentiable and increasing for all real numbers. On what intervals is the function g of x cubed minus 6x squared increasing? So I need to find the derivative, and this is the derivative with the chain rule, so it's going to be y prime is equal to g of x cubed minus 6x squared times the derivative of the inside function, which is going to be 3x squared minus 12x. And what we do know is that g of x is increasing. So this is my g of x. I know that this is increasing. Okay? And so what I don't know is where this part of it is going to be increasing. And so I will set this guy equal to 0 and solve. I'm going to factor out a 3x, that leaves me x minus 4, and so x is 0 or 4. And on a number line, if I test these intervals, I'm going to have positive, negative, and positive. So increasing will be from negative infinity to 0 and 4 to infinity. For number 5, for what values of x does this function have a point of inflection? And I'm just going to recall my position, velocity, and acceleration. A point of inflection on a function is going to be where the second derivative, y double prime, is going to change from negative to positive or positive to negative. And so I'm going to find my second derivative. So that's 15x to the 4th plus 40x cubed, and then y double prime is 60x cubed plus 120x squared. And so set that guy equal to 0 and factor out a GCF. And so I'm going to have at x is 0 or -2. And so let's check them. Okay, so I'm looking for where the second derivative changes from positive to negative or negative to positive. This first interval, if we test a value less than -2, is going to give us a negative. If we test a value between -2 and 0, this interval is going to give us positive. And then the third interval, something greater than 0, is going to give us a positive. And so we are going to change from negative to positive at -2. Number 6. So we're given this equation that relates those variables if x is decreasing at a rate of 1. So I know that's dx dt, and that is decreasing at a rate of 1 unit per minute. dy dt is increasing at a constant rate of 4, so I know that's +4. At what rate is w changing? And so that's the question, dw dt. And we know that x is 6 and y is 20. So if I find the derivative of this function, dw dt is equal to, and this is going to be the product rule. So derivative of the first times derivative of the second, times the derivative of the second, plus the second times derivative of the first, all right, and then let's substitute in. So dw dt, 6 squared is going to give you 36. dy dt is going to give you 4. And dx dt is -1. So 36 times 4, I don't know what that is, it's a big number, plus 20 times 12 minus 1, times -1, sorry, that's a product, that's going to give you -96. You can double check that, but I believe it's -96. Number 7, let f be the function defined by this. On which of the following intervals is the graph of f decreasing and concave up? Okay, so decreasing is where f prime is less than 0, and concave up, that's where f double prime is greater than 0. So we need to do both. So f prime of the function is 6x squared minus 6x minus 12, and if I set that equal to 0, I'm going to divide everything by 6, so I have x squared minus x minus 2, and then factor that, x minus 2, x plus 1, and so I have, this guy is going to give me +2, and the second factor is going to give me -1, and if I test these intervals, I'm going to end up with positive, so we're increasing up to -1, we are decreasing between -1 and 2, and we are increasing after 2. And then now let's check f double prime. And if I find the derivative of the function, that's going to give you 2x minus 1. And set this equal to 0, and so we're going to get x is equal to ½ All right, let's check half. So it's going to be negative less than ½ and positive greater than ½ And so I'm going to kind of marry these two together. On that first number line, 1/2 is going to be somewhere in here. And I know I'm looking for, so all of this is concave up. I want to be decreasing in concave up. Sorry about that. So I want to be in this little interval right in here from ½ to 2. Okay, number 8, the figure shows the derivative, so that's just f prime, and between -6 and 8 on the interval, which best describes the graph of f on the same interval? Okay, so we did this back in, I don't know, unit 2 when we were looking at derivatives. I know I'm going to have a max here because it's going from positive to negative. I have a 0 slope here. It's not going to be a max or minimum. It'll have that cubic little flat area in the function, but it's all decreasing in that area. And I'm going to have a minimum over here. I know anything above the x-axis I'm increasing, and anything below means I'm decreasing. And so if I go through my options, I have 1 relative minimum, 1 relative max, 3 points of inflection, and that's going to be the answer. And okay, so let's see if I can explain that. Here's my velocity, position, velocity, and acceleration. And so I know I'm going to have a point of inflection, and this is where your first derivative changes from decreasing to increasing or increasing to decreasing. And so here is 1 point of inflection, here is another point of inflection, and the last one right here. So those are the 3 points of inflection. I should say inflection, not reflection. Number 9, let f be the function defined here. Is f continuous at 1, y or y not? Okay, so let's see what this is. So if I go from the left side, I'm going to evaluate the function, this first guy, at 1, and so I believe that gives me 10 minus 2 is 8, minus 1 is 7. So the limit as x approaches 1 from the left of f of x is equal to 7, and the limit as x approaches 1 from the right of f of x is going to be 1, e to the 0 is 1, so that's also 7. And what is the function at 1? All right, so I'm going to plug it into just the top function, and that equals 7. So yes, because it is continuous, because the left side limit is equal to the right side limit, and the function is equal to that value. And number 10, particle x moves on the positive x-axis, so its position is given by this function. Is the particle moving left or right at 1? Okay, so let's find the derivative so we can find where it's left and right. Remember, if it's greater than 0, it's moving to the right. If it's less than 0, you're moving to the left. And so x prime of t and set this equal to 0. So I'm going to factor out, what, 3t. And so it's going to give you, the first factor is going to give you 0. The second factor is going to give you 6/5. And if I test these intervals, actually, all I have to do is, I don't have to test intervals. Let's just evaluate the derivative at 1. So let's just do that. Sorry, guys. So if I plug in 1, that's going to be 15 minus 18. That's negative, because x prime of 1 is less than 0. And we're moving left, so I believe it's this guy. Okay, 11, particle x moves on the positive x, so its position is given by this. At what time is it furthest to the left? Okay, so that's the same function as the last one, right? Yes. So my derivative is 15t squared minus 18t. And when I factored out 0 and 6/5, okay, so if you're going to be left, furthest left, we're going to find out where this function, or where this particle is going. So let's test these intervals. Let's see what direction you're going. So left of 0, oh, and that's time. So I don't need time less than 0. So forget that. Let's just test between 0 and 6/5. Well, easiest value to test is 1. So if I plug in 1, we already know that that's going to give us a negative value. And so we're moving left in this interval from 0 to 6/5. And then remember, this is where we hit 0, so we stop. And then after 6/5, the interval is positive, so we move right after that. So we're moving furthest left at a time of 6/5. And that's because we change from negative to positive. All right, I think this is the last one. Particle moves on the x-axis, same thing. A second particle moves on the positive y-axis, so its position is given by this. The origin and the positions of the particles x and y are vertices of a triangle in the first quadrant. Find the rate of change of the area of the triangle. Yikes. Okay, so I do know on if I'm looking for rate of change of area of a triangle, that's not too bad. Area is, what is it, 1/2 base times height. And if I want to find that rate of change of the area, well, that's just the derivative, dA dt. And I have the product rule again. These are my two factors. So first times the derivative of the second plus the second times the derivative of the first. Okay, and let's plug in what we know. So if we want to find this guy, and 1/2, what I don't know is where this particle is. So let's find that out. Let me do a little scratch work. And we're looking at a time of 1. So let's find the first particle at a time of 1. Where is he? So it's 5 times 1 cubed minus 9 times 1 squared plus 7. So 5 minus 9 plus 7, and that's going to give you 12 minus 9 is 3. So that's where this guy is. And this is moving along the x-axis, and I consider that the base. So that's 1/2 times 3. And the rate of change of 1, let's see. Yeah, so the rate of change, well, that is x prime at 1. And thought we had that, maybe not. Yeah, x prime of 1 is -3. I think we figured that out in the previous problem. So plus the height of the second, so y at 1 is going to give you 10. 7 times 1 plus 3 is 10. And the rate of change of the second at 1, so y prime is equal to 7. Okay, let's see if I can calculate this right. So this is going to give you -9/2 plus 5 and 1, so 35, -9/2 plus 70 halves, and I think I just did it wrong because that's going to give you what, 61 halves, and that is none of the answers. So let's see what I did wrong. 1/2 times rate plus h times, so 1/2 times 3 times the rate of change. Oh, I see what I did wrong. Sorry, guys. That should have been 7. It dH dt. I put my numbers backwards. And that should be -3. So, quick fix. So this is 21 halves, -15. So 21 halves plus, and that's going to give you -30 halves, which is going to give you -9 halves. And